இந்த ரெக்கார்ட் சிம்பிளே வர மாட்டேங்குது. சிம்பிள் வரணும்ல ரெக்கார்ட் சிம்பிள். இப்போ ரெக்கார்ட் ஆகும். Let us continue the sums. Now we will take in the previous sum. For previous sum, what is the value in the sense? 1.86 is the answer. For previous sum, answer is 1.86. Now let us go for next sum. 60 ml of H2. 60 ml of H2 and 42 ml of I2. 42 ml of I2 are heated in a closed vessel. Are heated in a closed vessel. Are heated in a closed vessel. At equilibrium, the vessel contains. At equilibrium, the vessel contains 28 ml HI. 28 ml HI. Calculate degree of dissociation of HI. Calculate degree of dissociation of HI. Calculate degree of dissociation of HI. Sir, here we are taking a H2, I2 we are taking. We are heating the contents. At equilibrium, HI is formed. Degree of dissociation we have to find. They are asking. Now, what are the things we are taking initially? H2 gas plus I2 gas gives 2 HI gas. 2 HI gas. Initially, what we are taking in the sense 60 ml of H2. Here it is given in volume. It is given in volume in the sense on the basis of what in the sense volume is directly proportional to number of moles when temperature and pressure are constant. Based on this, volume is directly proportional to number of moles when temperature and pressure are constant. Based on that only it is given. Okay. Therefore, we will take volume in terms of number of moles. 60 ml means 60 moles, like this we can take, or 60 millimoles, like this also we can take, or you take as it is. As it is, that ml only we will write. Okay, so ml only we will write 60 ml. I2 is how much means 42 ml. Now, at equilibrium, if we see how much HI produced in the sense 28 ml produced. 28 ml of HI is produced. That means, see, 1 ml of H2 on reaction gives 2 ml of HI as per stoichiometric reaction. So 28 ml of HI on reaction produced in the sense how much H2 would have reacted? 14 ml would have reacted. Correct? In the same way, I2 also 14 ml would have reacted. Okay. So at equilibrium, how much H2 and how much I2 will be there? We will see 60 minus 14 we will take. Therefore, 46 ml. Here 42 minus 14 we will take. Therefore, here 28 ml. Okay. So this much is there. Now we will go for a Kc. Kc is equal to concentration of HI power 2 by concentration of H2 into concentration of I2. Concentration we can write it as number of moles by volume of system. Here number it is HI. Now number of moles of H2 by volume of system. Number of moles of I2 by volume of system. Volume of system get cancelled. So number of moles of HI square. Number of moles of H2, number of moles of I2. Now we know number of moles is directly proportional to volume. Therefore, number of moles of HI in that place we will write 28 ml. We will write number of moles of H2 we will write 46. Number of moles of I2 we will write 28. So we got what in the sense Kc we got Kc. Okay. So Kc is equal to 28 by 46. We got Kc. What we have to find? Degree of dissociation. Degree of dissociation of Hi we have to find. Okay. We want what in the sense degree of dissociation of Hi we want to find. Sir, how to find degree of dissociation of what? Hi. Degree of dissociation of Hi we want. So degree of dissociation of Hi we want. So for that, how to write equation we'll see. Dissociation of Hi we want to take. Okay. So dissociation of Hi in the sense Hi dissociating to give what in the sense H2 and I2. Hi dissociating to give H2 and I2 will balance like this will balance. Okay. So initially let us take 1 mole of Hi. 1 mole of Hi. So how much dissociating means alpha moles will dissociate. Degree of dissociation will dissociate. If initial is 1 mole, then dissociation will be degree of dissociation. Okay. Sir, at equilibrium we will take how much will be there means 1 minus alpha will be there. Okay. So how much H2 will be formed that we will see. Now 2 moles of Hi on dissociation gives 1 mole of H2. So alpha moles of Hi on dissociation gives alpha by 2 moles. So alpha moles of Hi on dissociation gives alpha by 2 moles of I2. Alpha by 2 moles of I2 we can say. So for this we will say Kc dash is equal to concentration of H2 into concentration of I2 by concentration of Hi square. Concentration of H2 into concentration of I2 by concentration of Hi square we said. Okay. Now concentration of H2 we can say number of moles of H2 by volume, number of moles of I2 by volume, then number of moles of Hi by volume square. Okay. So volume get cancelled. So we can say number of moles of H2, number of moles of I2, number of moles of Hi square. Number of moles of H2 is how much in the sense alpha by 2. Number of moles of I2 alpha by 2. Number of moles of Hi is how much means 1 minus alpha square. So we want alpha. Alpha is called degree of dissociation that we want to find. So we have to substitute Kc. So we want Kc for this equation. So this equation Kc we want. Whether Kc is given or not means for this dissociation of Hi, Kc is not given. But we know Kc for this equation. We know Kc for this equation. This equation and required equation, you see that how it is there means this equation and this equation are reverse. Therefore, what is the Kc for this equation? Reverse is the Kc for the required equation. So for this equation, what is Kc means reverse of previous equation. For this equation, Kc is what? Reverse of previous. Reverse of previous means this is the previous. So reverse it. So reversing it in the sense we'll get 46 by 28 is the Kc. Okay. So we know Kc for this, that Kc is equal to, now we can say here alpha by 2 by 1 minus alpha square. Okay. 1 minus alpha square. This we will simplify. This on simplification we will get alpha, that is called degree of dissociation. That degree of dissociation is how much in the sense 0.719. 0.719. So this is the degree of dissociation of a hydrogen iodide we can say. Let us go to next sum. 1 mole of H2, 1 mole of H2, comma 2 moles of I2, 2 moles of I2, and 3 moles of Hi, and 3 moles of Hi. Now in the previous problem, alpha will be only one value. We will not get two values. We will get only one value only. Positive value we have to take. Okay. Now we will continue this. This one will continue. That means here you are asking that it is quadratic expression. Alpha will get two values. You are getting. You are saying no. Alpha will be always positive and also less than 1. Okay, so if we simplify also, we will get a, if we simplify, you will get alpha value, how much you will see it. So this we will write it as a 46 by 28. So here alpha square by 2 square into 1 minus alpha whole square, take square root on both sides. So we'll 46 by 28 is equal to what, in the sense alpha by 2 into 1 minus alpha. Okay. So now if how it will be quadratic expression, it is not quadratic expression. Okay. So we will get alpha is equal to 0.719 only we will get. Okay. So we'll go to next sum. 1 mole of H2. 1 mole of H2, 2 moles of I2 and 3 moles of HI are injected in 1 liter flask, are injected in 1 liter flask, are injected in 1 liter flask. What will be the concentration of, what will be the concentration, what will be the concentration of H2, I2 and HI at equilibrium at 500 degrees Celsius. Kc for the reaction, Kc for the reaction, H2 plus I2 gives 2HI is 45.9, is 45.9. Okay. So let us go to the sum. So now we will take the given equation. Given equation is what, in the sense H2 plus I2 gives 2HI. Okay. Now initial moles we will see. Initially how many moles of H2 is taken, means 1 mole of H2 is taken, 2 moles of I2 is taken and 3 moles of HI is taken. Okay. Sorry. Now, so initially we have taken 1 mole of H2, 2 moles of I2, 3 moles of HI we have taken. Okay. At equilibrium, what is the moles of H2, I2 and HI? So we should know whether forward is taking place or backward is taking place. We should know it. Whether system is at equilibrium or not at equilibrium, first we should know it. So first what we have to find means whether the system is at equilibrium or not at equilibrium. Then only we can say whether forward is favoring or backward is favoring, we can say. So first we will find QC. So QC is equal to number of moles of HI square by number of moles of H2 into number of moles of I2. Instead of writing concentration, we are writing number of moles. Why? Because total stoichiometric coefficients on left side and right side are equal. So volume term will get cancelled. So that we have written number of moles directly instead of concentration. Okay. So HI is 3 moles that we have substituted. HI 1 mole, I2 2 moles. So we are getting what, in the sense QC we are getting, QC is how much, in the sense 4.5. So we got QC. Now this QC we will compare with this KC. KC is 45.9. QC is less than KC. Therefore, what happens means forward is favoring. Forward is favoring, we can say. Okay. Forward favors. Set. So now we will go for reaction. Forward is favoring. So X moles of H2 is reacting. X moles of I2 is reacting. So system is attaining equilibrium. At equilibrium, it is 1 minus X. It is 2 minus X. It is 3 moles. Initially, we have taken 2x moles is produced. 2x moles of HI is producing. 3 moles initially we have taken. So how much HI is there, means 3 plus 2x moles is there. Now we will go for Kc expression. Kc is how much, means 45.9. That Kc will take, that is equal to HI moles will substitute 3 plus 2x whole square by H2 moles will substitute 1 minus X. I2 moles will substitute 2 minus X. So we will simplify this and we will calculate X. Okay. So X is how much, in the sense 0.684. So we got X. From the X, we can say number of moles of H2, I2, everything at equilibrium, we can say. Okay. So now concentration of H2 at equilibrium is equal to number of moles of H2 at equilibrium. Why? Because volume is 1 liter. Volume of flask is 1 liter. Number of moles of H2 is how much? Initially, we have taken 1. 1 minus X is the number of moles of H2 at equilibrium. That is how much, in the sense 1 minus 0.684. Therefore, H2 how much we are getting, in the sense 0.316. Similarly, I2 is equal to how much, in the sense 2 minus X. Substitute X. So we will get I2 will get, that is 1.316. Then HI will see, HI means 3 plus 2x, 3 plus 2x, x substitute x, we will get HI will get, that is 4.368. Okay. So this is the concentration of each at equilibrium. So concentration of each at equilibrium is set. Okay. Let us go for next sum. 0.96 gram of HI, 0.96 gram of HI, hydrogen iodide, were heated to attain equilibrium, were heated to attain equilibrium. 2HI gives H2 plus I2. 2HI gives H2 plus I2. 2HI gives H2 plus I2. The reaction mixture on titration. The reaction mixture on titration. The reaction mixture on titration requires 15.7 ml of 15.7 ml of n by 10 hypo solution. N by 10 hypo solution. N by 10 hypo solution. Calculate degree of dissociation of HI. Degree of dissociation of HI we have to find. Okay. So here what is the word given in the sense titration word is given. What is meant by titration? Titration in the sense minimum 2 solutions we will take. Titration in the sense minimum 2 solutions we will take, solution number 1 and solution number 2. One solution concentration will be known. Another solution concentration will be unknown, that we have to find it. That is called titration. So in titration in the sense 2 solutions will be given. One solution concentration will be given. Another solution concentration we have to find. Okay. So how to find this? Sir. Now titration means what are the apparatus required, that we will see. One is called burette. One is called burette. Another one is called pipette. Another one is called pipette. Next one is called conical flask. Next one is called conical flask. Okay, these are the next test. Burette stand. Burette stand. This we have to take. Sir, how burette will be there? That we'll see. How burette will be there in the sense burette will be like this. Burette will be like this, will be there. Burette will be like this. Burette will be present. Okay, burette is present like this. In this burette, values will be engraved. First year 0 ml, year 1 ml, year 2 ml. Like this will be engraved till how much in the sense? Suppose 50 ml. If it is 50 ml burette, like this. 25 ml burette is available, 10 ml burette is available, depending on the requirement. Which you want to take, that you take it. Okay, it is burette. So in this burette, you take any one of the solution you take in the burette. So suppose solution 1 we are taking in the burette. So what we have to do means first wash the burette with water and rinse the burette with this solution number 1. What is meant by rinsing? Rinsing in the sense add small amount of this solution 1 and bring this solution 1 to every part of inner part of the burette and drain it out and remove that solution 1 from the burette completely. Now the burette is with what in the sense? Burette is not with water now. Burette is with the solution number 1. Okay. So now whatever the solution number 1 is there in the burette, that is drained out. That is removed out. Okay. Then now you add solution number 1 till go on add like this. Go on add the rise in the rise of solution. The solution level in the burette rises. When it comes just to 50 ml, be careful. Add drop by drop such that lower meniscus of the solution 1 must be coinciding with this 50 ml. Otherwise you add solution 1 over 50 ml, add it. over 50 ml added. That means you are adding solution 1 up to this level. Up to this level you added. Then what you have to do means, now here stopper will be there. Open this knob, and if you open, solution will come down. This solution, this level goes on coming down. When it is coming about to 50 ml, be careful. Make the solution to come out drop by drop, such that lower meniscus of the surface of the solution coinciding with this 50 ml mark. When it is coinciding, you stop the flow of solution out. Now the surface of the solution 1 is coinciding with the 50 ml. Okay. Now burette solution is ready. Next we will see pipette. How pipette will be there, we'll see. Pipette will be like this, will be there. Okay, it is a pipette. Pipette will be like this, will be there. Okay. Here it will be marked. What will be marked in the sense 10 ml, 20 ml, 5 ml, like this will be marked. Which pipette you want, that pipette you take. Suppose if you want 20 ml pipette, 20 ml pipette, if you want, you take 20 ml pipette. First wash the pipette with 20 with water. Then wash this pipette, rinse this pipette with this solution number 2. Because solution number 1 we have taken in the burette. Now rinse the pipette with the solution number 2. Then in the solution, in the pipette, your mark will be there. Here suppose 20 ml is given in the sense, up to this if you take the solution, then that is called 20 ml of solution. Now it is rinsed, and the rinsed solution is thrown out